Okay, so are you seeing this screen, Abdullah?
Yeah.
Okay. Do you see a create button at the right side?
Yes.
You need to click this and then you need to click circuits. Okay. Let it load for a while. Okay. So this is a fresh new screen. This is the work area and you can drag the components from the right side and you can place it in this work area to give connections and to play with different components. We are going to start with a battery. Okay. So this is a 9-volt battery. You might have seen it in the toys. So you click it and then you move the cursor and then you click it again in this work area. And now you successfully placed a component. Okay. But this component is horizontally placed. You see, generally we keep the batteries in the vertical position, right? So this is not in the vertical position. So you need to click the battery and you need to press the button R. So if you click the button R for rotate, it will come in the vertical direction. Okay. So if you want to move the component, you click it and move the cursor. I mean, you need to select the component, you need to click the component, and then you need to move. Okay. We have taken the battery. For a basic electrical connection, I'm going to add a bulb. Okay. So you can go here and search for the components which you are not seeing right at the top. Okay. Otherwise, you need to go the components one by one and then you need to select it. So here I'm going to type bulb. You're getting a light bulb. Okay. So I am placing the bulb here. So I am having bulb and I am having battery. So I'm going to run the simulation. I will explain you what is simulation. Simulation means a virtual environment is created. I mean, it's not a real scenario. You can take your video games as an example. You are playing car games. You are seeing a car moving in the screen, but you are not actually driving the car. The car is virtually driven. So you are moving the mobile here and there, and you are tilting the steering wheel, and you are doing all those stuffs. But a real car is not moving. Virtually, a car is moving in the screen. So if you make something virtual, if you make some artificial environment of a real world scenario, then that is called simulation. Okay. So here we have created an artificial scenario, like the battery and bulbs are real components in the physical world, but here we are having a pictorial representation, and we are making this bulb to turn on. So that is called simulation. Okay. Now I'm going to click start simulation. Do you think this bulb turns on?
No.
So it doesn't turn on. Why is it?
Because there's no connection.
Yes. You don't have any wire connections between the bulb and the battery. So I'm going to connect it. If you see, this is plus and this is minus. Generally, the positive sides are colored with red color and the negative sides are colored with black color. Okay. So if you want to connect 2 points, I mean, this is called as terminals. In electrical terminology, these points are called as terminals. Okay. If you want to connect 2 terminals, you can do so by selecting one terminal and then selecting the other terminal. So the connection is complete. Okay. To be consistent, I am going to change the color of the wire. I'm going to make it as red. Now, if I click start simulation, do you think it will work?
No. No.
It will not work. It doesn't work because of what reason?
There's no complete connection.
Yes. So I have connected only one side, the other side is still open. This is called as open circuit. Okay, you don't have a closed circuit. This is called as closed circuit. So the current comes out of the battery and flows into the bulb and comes out of the bulb and goes back into the battery's negative terminal. So this is called a closed, because you are closing the circuit, right? So this is called as closed circuit. And by convention, this should look like a black wire. So I'm changing the color of the wire to black. Okay. So now if I start simulation, do you think it turns on?
Yeah.
Yes. So now it's glowing. The bulb glows out some light for us. So this is a real world scenario, that even if you take a bulb, real bulb, and then if you take a real battery, you need to make this connection to get it complete. So you have understood this, right?
Yes.
Okay. I'm going to stop the simulation. So if you want to make any change to the schematic, I mean, if you want to change the wire connections, you need to stop the simulation and then you need to make the changes. Otherwise, Tinkercad doesn't allow you to make any changes into the schematic. So I'm stopping the simulation. Now I'm going to connect this negative terminal of the battery to the terminal 1 of the bulb. Do you think the bulb glows when I click start simulation button?
No.
No. Why it doesn't?
Because
Because it
it's
is
not
still a open.
connected to
Yes.
terminal 2.
Yes. So the terminal 2 is still open. So you need the wire connections appropriately. Okay. So this is a kind of a short circuit that we can see later. So you should not have any connection like this. Okay. So in electrical world, you need minimum 2 connections. Okay. You need minimum 2 connections between a source. Here, the battery is the source. Battery is providing power and the bulb is consuming the power. So between a source and a consumer, there should be minimum 2 connections to complete the circuit and for the circuit to work properly. So battery is the provider and this bulb is the receiver, and the bulb converts the electrical energy into the light energy. Okay.
Okay.
Now another question. If I provide connection like this, does it work?
Yeah.
Yes, it works. So even if you interchange the connection of bulb to battery, it still works. So when we say connection, it means a line that connects 2 points. Okay, that is single connection, single wire, and this is the connection number 2. Okay, it still works. So if you want to move, previously I explained about moving the components. Okay, now I'm explaining you how you can move the workplace. So if you click it and then move your cursor while clicking, so it will, this is called pan. Okay, you can move the work area like this. Okay, if you want to move the component, you need to click and then drag it. If you want to move the workplace, then you need to click the workplace and then drag it. Okay, suppose if you want to zoom, you need to follow this method. You click it, you use your 2 fingers, you click it and then drag it in opposite ends. Okay, so that will zoom, that should zoom the workplace. Okay, or if you have mouse, you can use this scroll button. This roller can be used to scroll uh, scroll to zoom your work area, and this is panning. So you can click it and then you can move the screen right or left or top or bottom. Okay, Okay. So in power adapters, you might have seen a small red color light, right? So that's not actually a bulb. That is actually called as LED. I will tell you the abbreviation. So this is LED, which means light emitting diode. Okay, LED means light emitting diode. So that's not bulb, that's LEDs. They are very small in size, and it can consume very small amount of power. So we cannot use bulbs in adapters because bulbs are a little bit bigger in size compared to LEDs. So, and they consume more power. Okay, so let's go to LEDs. You see, this is LED. You click it and you drop it. Now I'm going to delete this bulb, keeping it here. I'm going to give connections. Okay. Now if I click start simulation, do you think it works?
No.
So it doesn't work. So when it comes to bulb, it used to work, right?
Yeah.
When it comes to bulb, if I move the same connections like this, it works. But when it comes to LED, it's not working. There is a very simple reason you can see from the schematic. If you notice the terminals of the bulb, they are exactly same. If you don't keep your cursor on terminal 1 and 2, you don't see any difference between these two terminals, right? They are looking exactly alike. So if I keep the cursor on the terminal 1, it shows terminal 1, and this one shows terminal 2. But if you see the LED, it is different. You see, this one is a straight line and this one is a curve, a little bit skewed. So this is positive and this is negative. Okay, when you are connecting positive to negative and negative to negative to positive, negative to, I'm sorry, I confused. So this is positive and this is negative. I'm connecting positive to negative, and here this is negative and this is positive. I'm connecting negative to positive. So I am making a wrong connection. So this negative leg is called as cathode and this is called as anode. You don't have to memorize these terms as of now. So I need to provide a proper connection since the LED has plus and minus. Bulbs don't have positive and minus, but LEDs do have, and we need to provide a proper connection. So this is positive and this is negative. Okay. Okay. Now you are having battery, you have LED, and then you have a proper connection. Correct. So
Yes.
if I click start simulation, do you think LED would glow?
Yes.
But you need to prepare for a surprise. Do you see what it is showing?
It's burning.
It is burning. So it is glowing, but to the extent it burns itself. Okay. So the solution is to add a resistor. So here we need to add some component called resistor that will keep away the LED from getting burned. Okay, so if I stop simulation and add resistor, it will solve the problem. Before that, we can discuss about couple of other ways. Okay, the battery is producing a huge current for the LED that it cannot tolerate. Okay, so we need to bring down the current. The current given by the battery is too much for the LED to bear. Okay, so if you scroll down or if you search, you can add few batteries into your workplace. So if you read, this is saying 9 volt. This is a 9 volt battery. And here, if you read, it is saying 3.0 volt. And this one is 1.5 volt. Okay. So if I connect LEDs individually, I'm going to rotate it. Okay, I think. Okay. So I can start simulation. You can see the differences. The light intensity is very low here. The intensity of the light is very low. Here it is having a decent intensity, and here it is burning. So 9 volt is making the LED to burn. 3 volt is making the LED to glow decently, and 1.5 is producing a very low intensity of light, right? So we have learned what happens when a 9 volt battery is directly connected to LED without actually spoiling the LED. So you haven't spent even a single penny to do this test, right? So that is the advantage of doing a simulation. Okay, when you are well versed in the simulation, for example, we are going to deal with a microcontroller that costs hundreds of rupees. So if you mishandle the microcontroller and if you burn it, you need to spend again lots of hundreds to buy a new component. So I want you to fully understand the connections and components. You need to fully understand the fragility of the components, and you need to fully understood the background of the connections, and then we can move to real microcontrollers and real components. Okay, so with this I conclude this session, and we can meet again in the next session. Okay.
Okay.
Okay, so we will talk about resistors and how resistors are protecting the LEDs in the next session. Okay.
Okay.